Yeah, so I'm recording it. So, all right, let's get started. So first thing is announcements. So Lab 5 and Lab 6 are both due next week. I wouldn't worry too much about that because Lab 6 is like really short. I hope you guys can all get it done this week, like in lab section. It's not that, I mean, like you have to learn new stuff, but it's not a ton of work. And there's also a quiz today on 2D arrays and exceptions. And Project 2B grades will be released next week. So that's it for the announcements. Let's get started on version control. Okay, so version control is basically we have a problem. And that problem is how do we keep track of a project? And what do I mean? Like we have, for example, like for us in this class, like, yeah, you work on your own. But outside of this class, like if it's a group project or if you're out in the real world or something, like code is constantly edited with lots of people collaborating, right? And there can be a ton of files. It may not just be one file. Like in much larger projects, like as it gets more complex, like these become problems. Code is edited frequently, like when people make changes, a lot of people make changes, and there are a lot of files to deal with. Maybe experimental features. And so like we need some way to keep everything in line, right? Because there's a lot to like there's a lot of stuff that can change. So we have a solution. And one of them is a repository. The repository is just a place where all the files in a project are stored. And it also keeps track of their version history. The version control system is the software that tracks the changes and it allows you to interact with the repository. So repository, all the files in a project, version control system, software that tracks changes and interacts with the repository. Okay, so that'd be kind of confusing now, but we'll get to understand it soon. Okay. So version control, big picture. So there are like four main things that version control helps with. Modularity. You can write software in like pieces in order to form a final product. Recoverability. Because we have the ability with version control to, as I said, track changes, right? You can recover stuff and go back to the last stable version. Maintainability. You can evolve it over time to meet needs. And stability. Even if software changes, like you can keep deploy this version that's stable. So like one way you could think about doing this, for example, is like, I don't know, this is something I do, but like I don't recommend it, is like using Notepad, just like storing all of your old files in Notepad. But obviously that's not a good solution. So there's something better, and we'll talk about that. Yeah, so don't use Notepad as your version control. So yeah, we use Git and GitHub. So what's the difference? Like you guys may have heard of these before, and if not, that's perfectly fine. But you guys will get acquainted with them today. So Git is the version control system, and that's the software that maintains your local repository and like the remote repository. We'll talk about the difference in a minute. And GitHub is the actual repository. It's where you actually store your code. It's the repository says where you like store all your files and stuff, and it's online. It's stored online, so that's really nice. Yeah, and it's free. So yeah, okay. But the thing is that basically you have, I think I have a slide for this, so I'll get to it. Yeah, local and remote repository. So that's exactly what I was going to talk about. Yeah. So let's start with like the basic terms. So what is a remote repository? So a remote repository is where the most up-to-date code is stored, and that's the code that like everyone on your team or whatever can access, right? It's the one that's online on GitHub, and like you can access and change it and whatever. But then your local repository is where you take the code from and store it on your computer. And it's the local repository is just on your computer. So if I draw it out, right? So you have like your computer, and then you have like the main repository. And so like this is you or me or whatever, right? And this is the other people on your team or whatever, the other people contributing to the project. And all of you have access to this. You also then, once you have access to it, you might have a copy of it like on your computer, and you can make changes to that copy and then go back like and submit the changes to here so you can change what's actually available to everyone. And now these people can get the newest version. So now they have the changes that you made. So this one that everyone could access is called the remote repository, and the one that you have access to is the local repository. Okay, so yeah, the local repo doesn't update with the remote repository unless you specifically make it, and that's okay because you totally can do that. And yeah, only the user has access to their local repository. So the one just on your computer. Okay. So this is our general process with Git, right? It's everyone has to have a copy of the remote repository. You first have to clone the repo. So what does that mean? So cloning it is just like the first time you get it. There's like the repository here, right? And if you want to get this repo on your computer, you have to clone it. And then if you want to make any updates, like let's say, I don't know, this is like Alice and we have like Bob here. And like, I don't know, Bob makes a change and now like he updates it. Now Alice doesn't have the most up-to-date version anymore. So if she wants to get the newest version, she has to do a pull. So she pulls it. And what Bob did here, what he actually did to the repo, because he changed it, right? Making a change from your computer to the like online repo or the remote repo, it's called a push. So that's a push, that's a pull. Pull, you take things, push, you push things, right? So take things versus give things. Yeah, like push, you give things, pull, you take things. And yeah, he has commit early and often. So that's a general principle, but whatever works. Okay, so that's what we're going to talk about with GitHub, repos, all that, like version control. And like, I know when I first learned it, like this would not have been enough. So I'm sure it's not enough for like all of you, which is fine. We're going to go over like an example of how to actually use version control in a minute after this presentation. I'll walk you through it. But yeah, for now, we're just going to switch to exceptions, but we'll come back to this topic. Okay. So exceptions. So what's an exception? An exception is an event that occurs during the execution of a program, disrupts the normal flow of instructions. So basically, like it says, and yeah, programming languages can totally handle them. So like you may have seen these exceptions before, right? Where it says like, oh no, there's an exception in thread main, and like it actually stops the program. But the good news about an exception is that exception is a software thing, right? It's something where like the software says, oh, there's a problem here, we need to fix it. But the good news is that if software is causing that problem, software can also stop the problem or handle that problem, right? Like you know that there's going to be a problem with some input. You can say, okay, I know there's going to be a problem, so I'm going to deal with it. How? Well, we can catch exceptions, right? And so you won't get the scary text. So now, like for example, you can try and then catch. So basically here, you're trying to read in an integer, right? But what happens if the user puts in like hello? Like this, yeah, see? Hello like this, right? You put that in. Well, it's gonna try this. It's gonna say, okay, my scanner is .next in, right? And then, well, it's gonna fail, right? Because this isn't an integer. So if it fails, it goes into the catch input mismatch exception, right? So it does this, it does the catch because it fails. And so in the catch, it just prints that input wasn't an integer. And then it prints. Now notice if I put in, if the scanner, if instead of hello, I put in like 5, it wouldn't go into the catch block because it succeeded. Catch is like if it fails. So it's like try and do this. If it fails, then do this. And notice because it catches the exception, it doesn't actually give us an error anymore because the software handles it. It's like, oh, okay, you knew there was going to be an error, and we dealt with it. Okay. But you can also throw exceptions yourself. And this sometimes is good. I mean, I know exceptions may seem bad, but they can be good because they give you more information about what's wrong. So like, okay, in this example, you can try, and then instead in your catch block, instead of just having it throw some random exception, right? Now it's actually telling you some more information about what was actually wrong. So now throw new input mismatch exception, input was not a string. Well, now you know the input wasn't a string, and that's what the problem is coming from. So this might seem bad, but it's actually good because it gives us more information about what's actually wrong, like the actual error. So yeah, you can also like go ahead and you can throw an exception and then you can catch it yourself, whatever, yeah. But this is the idea of exception. Does anyone have any questions about throwing and catching exceptions so far? Because this is a topic that like will be covered on the quiz. Oh, yeah, okay, that's fine. Sure. All right. Yeah. I'll go back to the beginning sessions and try and go like, I'll walk through like a little bit. So like the idea of an exception, right, is like an exception is when you have an issue that like arises, right? And then what we can do instead, what we can do to deal with it is we can say, okay, we know there's going to be an exception. So we try and catch, right? So we have a try block and a catch block. As well, handling an exception you have to have is a try block and a catch block. The try block, you try and do something. And if it fails, it goes into the catch block and does whatever's there. So for the try, let's say we try and read in an integer. If it fails, we go into catch and do whatever's in there. And if the try block succeeds, if this actually works and it doesn't throw an exception, then we're good. Multiple catches for one try? No, you can't. I don't think. I know you can't have multiple tries for each catch, but I don't think you can. It's one for one, I think. So okay. Not exactly. Oh, it's the other way around? Okay, thanks, Hayden. Yeah, quiz today is also in 2 degrees. Oh, you can have one catches for one try. Thanks, Hayden. I did not know that. Appreciate it. Cool. Learn something new every day. You guys are great. Yeah, so this E here is just the variable name. This is the type. The type is an input mismatch exception, and your type is E. So, or like your type is input mismatch exception, your variable name is E. So this is just the name of the exception. Like the variable name is the type of exception. So yeah, you're just basically trying this, and then you're gonna catch it. And if you catch it, then you don't have to deal with the error. Like you do, this is how you deal with the error, right? This is like saying, oh, okay, there's a problem. Okay. Like you can use the variable name E. E is just a variable name, so like I could. Oh, you mean like? Sorry. Yes, you can totally use it. Yeah, good question. That was a good question. Yeah, I see what you mean. So like, E is you could use E. But generally, I think this is what Hayden was saying. Is yeah, like this catches exceptions of the type input mismatch. So like other exceptions can be handled in different ways. But like, yeah, this catch here, like this E, you could use, I guess, like you could throw E, but that wouldn't really be of much use. So yeah, generally it's kind of like placeholder. Yeah. But okay, now I'll talk about throwing an exception. Yeah. So and then I'll ask if you guys have questions, and that's fine if you do. So yeah, throwing an exception. So if you throw an exception, that like creates an exception. So like your program throws exceptions for you. So this here is when your program threw an exception. Like it does it for you because something went wrong. If you want something to go wrong in certain cases, like you want there to be a problem if the user puts in an integer or doesn't put in an integer, if you want there to be an exception thrown by the program, then you can do it yourself. You can say, okay, throw a new exception, right? Is that the breakpoint? So not quite. Like when you set a breakpoint, that's for debugging purposes. That's like when you are able to like step through your code. But this is kind of like a breakpoint point in a way where your program actually stops. A breakpoint is like your program still continues, but you can stop it. Like you can go and look inside of it. This, your program will actually stop. And then you'll have to like start the program again, like run it again in order for it not to have that error. Yep. So, right. But yeah, throwing an exception is like, okay. Oh, yeah, create breakpoint. Yeah, I'm sorry. Yeah, that is. Yes. Yeah, you're right. Right. I'm pretty sure what they did was like they made a breakpoint to stop there. But yeah, you're right. Sorry, I didn't read that very carefully. But yeah, so throwing an exception is like creates some sort of issue. It's not quite an error, and an error is different from an exception because an exception you can always catch. An error you can't. That's the difference between an error and exception. So when you see exception, you can catch that. And that's what issue. Or we threw in here. We tried, we caught, we threw. So throw creates an exception. Catch tries to catch whatever failed inside of try. Like try, you try and do something. Catch, if there's an exception, it'll catch it, or like it'll do whatever's in catch. And throw new exception, like gives an exception. Okay. And I know this is kind of confusing. I don't really use exceptions very often. I mean, they're useful. And you will have to use them throughout this course, but not a ton. And there are usually other ways to deal with things, even if there aren't great ways. So yeah, do you guys have any questions on that? On exceptions in general? Like if you still don't understand, that's fine. And I'll try and explain what you don't understand. Or is everyone good? All right, thumbs up if you're good. Like the little thing you can do. Yeah, that thumbs up. Awesome. Cool. Great. Glad to see so many thumbs up. All right, cool. Yeah. So debugging. So we'll talk about debugging now. So debugging, I'm gonna be honest, I don't use it very often either. Mostly just use print statements, but debugging can be very useful. So I'm not gonna say that it's bad or anything. It's a good thing. Yeah, so like it can definitely make the time that you spend like trying to fix your code shorter. So I highly recommend using it anyway. And yeah, the only reason why I don't use it is because I don't really use IntelliJ, but like for IntelliJ, it's like really good. Yeah. So okay. So we talked about unit testing before, right? Like that was, or we didn't talk about it, but it was something you used for your project most likely. It's how we tested your project A to A. So yeah. So right, we can use unit testing to test regularly. There are other ways of testing, absolutely, there are. But yeah, unit testing is a main way that people use. Right, and so you can test individual methods or groups of methods, edge cases and standard cases, assertions, boolean tests, and annotations, marking. So like here we annotate tests, and we like assert like this equals this, and it's gonna be like true or false, right? It's gonna say, yeah, it succeeded or no, it didn't. And then Boolean tests, like you return, oh, is it 0 or is it not 0? Yeah, and you can test all sorts of cases, right? Of course, like test cases can only go so far, but like if you create a lot of them, then they'll probably cover everything you need. I guess we kind of saw that with the last project. Like some of our test cases didn't even test everything. So people had issues trailing zeros, but in general, test cases are very good because they give us a lot of information. So how do we debug in IntelliJ? Well, you set a breakpoint like this. And a breakpoint just is somewhere where your program will stop during execution, where you can actually like step inside of it. and like look into it. So, okay. So this is a line of code that is going to execute, and we're going to stop that. We're going to tell the program, okay, stop there, and then we can tell it to continue. So, okay, right. So this green box here is we step through the code, right? Gives you options. You can step over, which is just like you go into the next line. It just keeps going next line. Step into means like it goes into the function that we're currently on. Force step into also steps into, and step out means like if you're inside of a function, get out of the function. Like after we step into this function, it's going to go inside of the function and try and execute this line. But if we step out, it'll just jump back to here. So frames, these are the stack frames. So this is what's like on the stack. So the stack is memory that, you know, I'm not going to get into this too much, but like it has like variables on it that are like accessible. Basically everything that's accessible from right here will be here, will be on this. So we have X because like from this line, right, we can still access X and we can still access Y. And so these are on the call stack. And then, right, and then also we have this, which is Z, so it's like our array, right? And this is all the stuff we have access to. So this is really helpful because rather than having like a print statement where you're like, oh, print X, like you want to see what the value of everything is, like this gives us information about everything at all times in the program. So you can just like go through one round of debugging rather than having like a ton of print statements, which can be really messy. So this is a lot neater. It's a lot easier, and there's like less cleanup. You don't have to like delete all your print statements. So this is really helpful. Oh yeah, so sorry, this is the variables. This is your call stack. So the call stack is like the different things that are different calls that are put on the stack. So it's like different method calls. So like, so far we just have main, but after we step into this one, it's going to say also say hello here. It'll be like, say hello, 11, or something like that. Okay, so this is how we debug. I know one of the other TAs made a video about this at some point, so I think her video is better than this, so on debugging. So I recommend watching that if you want to know more about debugging. Yeah, we'll talk about it a little more though. No, oh, sorry, yeah, this isn't on the quiz. The quiz is only on exceptions, and then mostly 2D arrays. Like it's like 1 or 2 questions about exceptions, and then it's mostly about 2D arrays. This is just something that's good to know because it can help. Yeah. So stepping over, you just like step over a line. You're just going from one line to the next inside of main. It doesn't enter methods, but it will run the methods. It just doesn't call. Like it doesn't go inside of them for you. If you just decide to step over, step into and step out of, actually go into methods and out of methods. So for example, if I'm meant to say hello and then I step into, it'll actually take me inside of the method. Whereas now if I'm inside the method, I'm on this line and I step out of, it'll just jump back to main. It'll leave the method. Yeah. And then it'll finish the method for us. Like it'll still run the method. It just, we won't have to sit and go through every single line of the method. Okay. Force step into, yeah. So right, it doesn't go into like generic functions, which is good. Because these are like, I'm not even gonna get to it. But yeah. Well, okay, I guess so. Because like system.out.println is like actually like a way more complex method. Like as you can see here, like this looks pretty difficult. And what's actually happening is like it's actually going into making a call to the like operating system kernel. Like the print statement is actually like takes a lot. Believe it or not, it seems like a simple method, but it requires a lot. Yeah, but that's okay. Like, so it doesn't go into methods like that, which is like a good thing. But if we want to go into them, you can use force step into, right? Instead of just step into. And it'll just run through the code. I won't go into like too much more than that, but like generally it's not really something that you need because println, like we know how that's going to operate, right? We don't have to like step into that method, but you can with force step into. So that's it for debugging. But do you guys have any question about anything I've talked about? Except for the version control, because I'm going to go over that a little more. Or even if you if you have questions about that, generally, like go ahead and ask those too. But I'm still going to go over them a little bit. So any questions so far before I go over an example of how we're going to do? I'll walk you through lab 6. So any questions before I do that? So on the quiz for exceptions, you shouldn't see anything too bad. It's not gonna be that much. And like, as long as you understand the idea that like the try tries to do it, and then if it fails, then it goes into catch, and catch will just execute whatever's there. But if it succeeds, then it doesn't go into catch. If you understand those things, you should be okay. Yeah, we can go over 2D arrays real quick. Yeah, sure. And well, let's do that now, I guess. Let me find like a mostly empty slide. Yeah, this one's like mostly empty. Okay. So sure, like for 2D arrays, like it's gonna be kind of similar to what we needed to know for 1D arrays in a way, because like there are similarities, right? So like if I make a new array, right? I don't know, say a 2D array here equals new int 5, 5. That makes, or let's say 5, 4. How many rows and how many columns does this make my 2D array? Awesome. Yeah, that's right. 5 rows and 4 columns. Awesome. That's entirely right. Yeah, nice job, guys. Okay. Now, if I say, all right, instead of this, let me do this. So now instead, I'm just going to delete that. I'm going to say, okay. And now is, or I guess let's leave it as 5, 4. Yeah. 5, 4. And in is ARR sub 0. And ARR sub 1 is equal to M. And then I do like M sub 0 is 5. Okay. And then I print like this all gets done, and then I do this. Then I print like, and I know this isn't proper to syntax, but whatever. And then I print like AR sub 0. And I know my handwriting is kind of messy, but can anyone try and tell me what that would print out? Error. Okay. So it won't quite give an error because like what I did was okay, like it's probably because it's really hard to read, but like that's okay. Yeah, so I made a new array. Let's just like usually something that helps. Right. Oh yeah, I'm sorry. Yeah, I meant no, you're right. I meant to do okay. Yeah, so you guys are almost straight. Like, okay, so like all of you, like I see what I did. I meant to do AR sub 0 sub 0. That's my bad. But like yeah, you guys all had the right idea, pretty much. Okay, so like let me just draw it out so you guys can all see. So we have originally we have 0, 0, 0, 5 rows, 4 columns. So originally we had this, right? So then this line here made it, right? And notice that when we use int, it initializes everything as 0, because we actually made this, right? If we only put like new int 5, for example, then like new int 5 and then we left the second one blank, it wouldn't have filled it in with zeros. That's only because we actually like this actually like it declares and initializes everything. But if we just did new int 5, that would have like basically 5 nulls, right? If I didn't have this, if I left this 4 blank, because I didn't actually specify what my other array is. But because I did, this actually creates that. this actually creates the arrays. So that's why we get it filled with zeros. Okay. But okay, now we drew it out. Let's go ahead and talk about what happens. So we set M is 0, AR is 0. So this is AR 0, right? It's row 0. So what I can think of this as is now 0, 0, 0, 0. This is what M points to, right? M points to that. All right, cool. What happens next? AR sub 1 is equal to M. So now AR sub 1 is row 1, right? So that's this row. So this row here points to whatever M points to. So this also points to this. Okay. And then M0 is equal to 5. Well, what is M0? Well, it's whatever M points to. It's its first element. We set it to 5. So notice that if we still are using this representation, right, because this is what this points to, this is exactly equal to it, right? So now they're both this. So if I print AR00, that's 5. AR10 is also 5 because they point to the same exact thing. So if I change one, I change the other. So it's kind of like what we talked about the arrays before, like 1D arrays. But something that's really important to keep in mind is that like they point to the same thing. Like if you set two arrays equal, right? Like an array equal to another array, they point to the same thing. So if you change one, you change the other. And that's true until you use the new keyword. So if I do this, right? If I say AR1 equals M, but then I say like M equals new int 3 or something, right? Then I'm using the new keyword. So now M no longer points to what AR points to. So once you use the new keyword, now they point different places. So this got kind of messy, but like, I will like go into that a little more in just a second, but like, is anything I've said like confused anyone? Oh yeah, sure. We can totally do that. Let me clear this in. Yeah. Hopefully like everyone was able to follow what I said though. So, but yes, I will go into that. Let's go over that, yeah. So, okay. So we'll come back to this, or I'll just open it in a new tab. So sure. Let me stop sharing for just a second, and then I'll go back to sharing. So number 4. Yeah, okay. Sure. Okay, cool. Yeah, so number 4 here. Okay, so what's going on? So make a new array, right? And if you know how to do these kinds of questions, like you should be good. So I think these are actually good ones to go over. Yeah. So make a new integer array, right? It's 2D array. It's 5 by 5, right? And so what this does is because we said new int 5, 5, this actually creates like our 2D array. So let's think of the representation as, we can think of it 2 ways. So let's just say, okay, we have like 0, 0, 0, 0, and we have 5 of them, right? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, but that's one way of thinking about it. Another way of thinking about it is like, okay, this is the 0th row, right? So this is AR0, right? Each row is its own array. Yeah, each column is like not a new array. It's stored in memory as like each row is an array. Yes. This is AR1. And when I say this, I mean like this whole row. So now I'm just going to do shorthand. I'm just going to write this as 2 and 3. But when I say 2, 3, and 4, I actually mean like AR 2, 3, and 4. Okay, so this is just for me to write less, and I don't have to write over the code. But yeah, so that's what I mean. So I'm just like drawing the arrow there. Cool. And so that's what they all like point to. But now what? Well, now I say, okay, AR2 is a new int 4. So now what that does is it says, okay, now the second row, so this one here, right, is no longer this because I'm resetting it to a different value. So now it's no longer that. Now it's just for long, but remember the default value for integer is 0. So it sets to that, right? And it says, okay, AR1 is equal to AR2. Okay. So what this does is it now sees what the AR2 is, like it sees what AR2 points to, and then changes what AR1 points to that. So now AR1 points to this. Okay. So it's no longer this. Now it points to that. So both AR2 and AR1 are both just 4 zeros right now. Okay. So what happens next? Next, we set AR3 equal to AR1. So we see now, okay, what does AR1 point to? Well, it points to what AR2 points to, which is just the 4 zeros. So now we do the same thing. Now AR3 is no longer this. Instead, it's going to point to this, right? The same thing as what the other two point to. So AR3 is no longer this. So then AR11 is 3, okay? So, well, what is AR11? Well, we go to what AR1 is, right? Because that's the first row. And then we change its first column to 3. So we see, okay, AR1 is this. We change first column to 3. Well, this is the first column, right? Because not the 0th column, it's the first column. We set it to 3. Okay. And then we set AR3, which is the third row, right? Row 3. And then column 3 equal to 6. So now we go column 0, column 1, column 2. This is column 3. And we set that to 6. So we print out AR2, so row 2, column 3. So what's row 2? It's this one, right? Row 2. We see what its third column is. Well, 0, 1, 2, 3, it's 6. So we print 6. We print a space. And then we check, okay, row 1, column 3. 0, 1, 2, 3. Oh, that's also 6. So it prints out 6, 6. Does that make sense to everyone? Did like, were you able to follow that? Is there something that was still confusing? Oh, cool. All right. Awesome. Yeah, I can go over 1 and 2 and then move on, I guess. Oh, okay. Or yeah, row 2, column 3 was 0. Okay, yeah, it's not quite 0 in this case because row 2, column 3, because in this case, like we actually have all of them point to the same thing. And since all of them point to the same thing, all of them have the same thing in their third column, right? Like it's transit, like equality in this case is like kind of like transitive because we never use the new keyword. So like when you set 1 equal to 2 and then 3 equal to 1, now like 1 equals 3, which also equals 2. So like all of them have the same thing in every position. And oh, and when I say column 3, I mean like 0, 1, 2, 3. So this is 3. Does that clear that up, Morgan? Yeah, okay, cool. All right, yeah, let's go over like 1 and 2 then, and then yeah, okay, cool. Let's go over 1 and 2, and then we can move on to like the version control stuff, which, yeah, I'm not sure if we're gonna even go into like breakout rooms today. We'll see. Okay, so yeah, number 1. So which of the following is gonna return null? So let's talk about this. This is a good question. So we have matrix, we make a 2D array, right? We say, okay, it's 5 rows, right? But right now, notice, I didn't actually set what the column lengths are. So right now, this is just null, 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 null. Because I made 5 rows, right? This makes 5 rows, but each of the rows is an integer array, right? Because this is an array of integer arrays. And because I only said what the rows are and not what the columns are, so far, I just have 5 integer arrays. But like I haven't actually made the arrays. And so the default type of an array is null. So I just have like 5 nulls. Okay. So then I set matrix 0 equal to new in 4. So that changes what's here in 0 to a new array of length 4. And remember, the default value for an array is 0, an integer array. And then I do the same thing with 1. I say, okay, matrix 1 is a new integer array of length 6. So 0, 0, 0, 0, 0, 0. Okay. And then the next line, I say, okay, matrix 2 is a new integer array of length 2. So now 2, I set 2, 0, 0. So now, if I do matrix 0, well, that here is not null, right? Matrix 0 is this, which is an array, right? It's an array of length 4. Tell you the number of rows. Oh yeah, 1D array tells you the number of columns. Yeah. Like this here is basically saying, okay, the 0th row, make it 4 columns long. So then, yeah, if we check like all these options, we're going to see that only D is null, and the other ones all have values. Okay, make sense? The one below it. So, oh, like 1, 1, you mean? Or this? Like, sorry, what do you mean by 1 below it? Yeah. Oh yeah, 2 nulls. So right, this is matrix 3, right? Because it's row 3. So matrix 3. And this one's also, no, this is matrix 4. Yeah, it doesn't give the option. Okay, cool. So let's go over the next question, and then if you guys have specific questions, I'll go over those, and then we can move on. Yeah. Okay. Well, what's the output? So again, we have the same kind of deal going on here, right? We have a 2D array, but so far we've only made the rows. We haven't made the columns or anything. So all 4 of our rows are just null right now, because all we said is we have 4 rows. Then we say, okay, the first row, or the 0th row, is now a new integer array of 2. So the default value of an integer array is 0. So we do 0. And then what? Well, we go to the next line, our code. We say, okay, matrix 1 is equal to matrix 0. Well, this is matrix 1, right? Because it's row 1. And this is row 0. So what is this doing? It is saying, okay, this is no longer null. Instead, what's here is just pointing to this. So we have matrix 1 and also matrix 0. This is 0. Okay. So what next? Next, we say, okay, matrix 0, 0 is equal to 3. So this is matrix 0, right? And this is column 0. It's like row 0, column 0. But more specifically, it's not just that. This is like the 0th row. Right? We're setting to 3. And then we say, okay, matrix 1, 1. Well, we set to 4. Well, 1, 1. This is matrix 1, right? And we're setting it's not the 0 element, the first element, right? Equal to 1. So we're setting this equal to 1, or to 4, sorry. But notice that also changes what matrix 0 was pointing to. So now when we loop through and print, we're going to get like just matrix 0. When we just print out what's in the 0th row, right? We're just going to get 3, 4, because matrix 1 and matrix 0 were both pointing to the same thing. Does that make sense? if it said matrix 1, 2 equals 4, that would give an error because like the length of this is only 2, yeah. Oh, no, it wouldn't. So for arrays, like it specifies an exact amount of memory only, so you can't go out of bounds or it will throw an exception. Yep. And which we just learned how to catch today. So yeah. Okay, cool. So hopefully that answers everyone's questions about this. Do you guys have any other questions about like 2D arrays or anything specific? Or should I move on to talking about like the lab for this week? All right. I guess I'll move on to the lab. So yeah, we're gonna talk a little about version control in this lab. So yeah, this lab is software engineering, lab 6. And so the first thing, I guess I should have said this at the beginning, but yeah, install Git for your OS if you need to. I think for Mac, you don't need to. For Windows, you should need to actually. So yeah, it doesn't take too long to download, but go ahead and download it now from here. Yeah, and then make a GitHub educational account. And when you do that, you can, when you make your account name, either I think you submit on Canvas. So either when you submit with your name, or make a name that I would recognize as you, because I know like last semester people were submitting names that like I didn't recognize them as, so like, it took a while to grade. Yeah, but okay. And then you create a private repository. You add, commit, and push your old lab folder or other code. You make a change and push again. So okay, what is that gonna look like? Well, let's go ahead and look at what it would look like. Okay, so yeah, right. So download Git, and then we're gonna do it. I'll walk you through today. Okay, so all right, so this is yeah, my GitHub. So I'm just gonna make a new repository. This is basically what you guys are gonna walk through. You're making a new repository, and let's call it just like, I don't know, lab 6 repo. And you're gonna make it private. Okay, so this is kind of what you guys are gonna walk through. So when you guys do this assignment, so you guys can even follow along now if you want to. Yeah, so no template or anything. You guys can just do this, create a repo. And so what that does is it makes this, right? So now, okay, so we made it. And now this gives us this thing here, which is good because like we can clone using this link, I think. Yeah, should be able to. So let me open up. So when you download with Windows, you get this Git Bash terminal. And if you did it, and if you have a Mac, you can just use your regular terminal, which you can find by like typing in CMD, and it'll just like come up with the command prompt. So for Mac, that works fine. For Windows, you need to download Git, and then you get this. Right. So then I can do like, first, I'm gonna make a folder. So I'm gonna cd into desktop. And what this does is it just goes into my desktop folder on my computer. And then I'm going to make a directory. Let's call it lab 6 repo. And this just like this command here just makes a directory. So it like just makes a file or a folder, sorry, not a file. Makes a folder called lab 6 repo. And then on my desktop. And then I'm going to go ahead and like cd into it. So cd, which means change directory. So it goes into my lab 6 repo. So it goes into the folder. And now if I want to see what's there, I can type, actually, I think in Windows it's dir. So dir, and no, nothing is there yet. Okay. But now I want to get, first I have to clone. So I'm going to do git clone, and then I type in this link. Awesome. Yeah, if you already have a bunch of repos, then that's great. You guys still have to do this assignment, but like, yeah, then I guess it should make it easier. I hope. So, yeah. but awesome. So then you clone it, clone it, and it just like creates it on in this folder. So now if I type dir, note that it actually created like the file or the folder, right? Okay, so now I'm gonna go ahead and change directory into lab6 repo, and this goes inside. I shouldn't have named them both the same thing, but whatever. This just goes inside of the other folder. And now if I type dir, there's nothing there yet, but let's see. Now I'm gonna open it in my file explorer. So it's on my desktop, right? I have way too much stuff, and that's okay. Yeah, lab6 repo, here it is. So notice how it created it. It has this .git here, which you need to have in order to actually have it like as a Git repo. This master means that it's like the main branch of it. So, okay. So now if I want to actually write some code, let's say I don't know, let's say I have some IntelliJ code. Let me see. I don't want to have anything. Let me see. No, I don't think that's good. Well, this is fine. No, it doesn't. Well, okay. If you want to use the, sorry, I should have mentioned that. For the student account, yeah, you need to use your UF email. So, good question. Okay, so let me just do like a public class blackjack. So I'm just going to write a really simple main here, just so you guys can see what I'm doing. Public static void main string args. And I'm just going to like system that out dot println. Hello. Yeah. Okay. And now I'm going to save it. Show and Explorer. Okay. And now what I'm going to do is I'm just going to go ahead and like take this file and just I'm going to drag it over here. Okay. So cool. So now I have this inside of my, notice how like this right here is my local repository, right? Because it's what's on my own computer. But the remote repository is what's here on GitHub. And so this is what we're going to want to push our code to, right? So we made our changes, or we made our changes, right? We have some code. Now if I type dir, notice now I have blackjack.java there. Okay. So now what I want to do is I want to push it to the remote repository. So what I have to do first is git add, which just stages it for commit, right? It just gets it ready so I can actually like push it. So now I do git commit -m. So all this is saying, okay, is like now we're like committing it, so we're about to push it. We're getting ready to push it. We have to give a message. So I am adding blackjack.java or something like that, or add blackjack.java. There we go. Okay, I hit enter. So as you can see, it's like it made a file change, right? But if I actually want to make the change so I can actually see it here, I have to do git push origin master. And the master here is because I'm on the master branch. Like you can have more than one branch, which means like a branch is just like, you can have like multiple different lines of the code, like, and then they can all like come together. So different people can work on different branches and then like you merge them all together. But for the sake of this class, you don't really have to worry about that too much. It's just like, you're always waiting for your origin master. So I git push origin master, and hopefully nothing went wrong. Yeah, cool. So now, right, it just makes the changes, and we're going to see here that the code changed. And now, see, it added it. So that's pretty cool. Okay. And the other thing you guys are going to have to do after that is make another change. So you can do like git pull. I think this is how you do it. Yeah, but it's already up to date. Doesn't matter. Like you try and pull it, so this gets the code again, but Sorry, update, so you don't have to worry about that. And then you make some changes. So actually, no, it's not fine if you do that. I prefer, yeah, like I know that's an option, is like you can actually upload the file, but the whole purpose of this is like to learn how to use version control. So like, yeah, use version control instead of uploading the file. Okay, awesome. Yeah, thanks. Okay, yeah, and then after that, what you guys are gonna do is you're gonna make another change to your code. So like, let's say I can go back into my code, right? I can open it up. For me, it opens in Notepad++, but whatever. And then make some change to it, like, I don't know, hello, make a comment, like, I made a change. And then after that, you guys are just gonna go ahead and push it again with the changes, like go through the same process again. And then that's about it. That's like the whole lab. I guess I will break you guys into groups for this lab. And then if you guys have questions, you can ask. But this is the main thing you're gonna have to do. And the last thing you have to do, and don't forget to do this. Yeah, don't forget to do this. You have to manage access, and I'm pretty sure I'll have to log in. Okay. I think, yeah, you're adding me as a lab intern. So after I put in my password, right, for manage access, then you can add me as a collaborator. And when you do that, that way I can actually grade it. Just make sure you do it. So put in my name here, Jimmy from robotics. I was never in robotics, but that's my name. Yeah, the recording will be posted. So this is how you go through it. Yeah, and so that's how you deal with version control. So that's what you're gonna be doing for this lab. Are there questions? Oh yeah, so click manage access. Put in your password that you signed up with, and then let's see. Does it actually? It doesn't show it, so I guess I can do it. Yeah. The lab is due a week from today, so the same day as the other lab. This one isn't, as you saw, it's like not a ton of work, so I basically just went through the whole thing. I mean, it's tough when you're first learning, but yeah. And then like, yes, then you invite a collaborator, so you just put my name. So you would put like Jimmy from robotics, which is just me. Yeah, I can't find it because it's me. So then you put that, and then you just add me as a collaborator, and then I can grade it. Okay. So are there any other questions on this before I like let you guys work on it? When you have questions, I'll like come by and help. But anything before then? You can name it whatever you want. Cool. So yeah, if you guys don't have questions, then I will split you guys into breakout rooms. And yeah. And you guys can stick around if you have a question, whatever.